Okay, so as we discussed in the Explorer, this was the summary of the Professor Splash data. So if you graphed him over time, you see that as he falls, the speed goes up, or the change in elevation keeps getting faster and faster and faster and faster and faster, which is what gives it that shape. And that's one of the indicators of something that's quadratic. But it doesn't just have to be something flying through the air, something falling like Professor Splash or the ball. So I want to actually show you another example of quadratics. And everybody's familiar with this idea of area. So we've done squares before in 8th grade. You've seen stuff like this before. So I have a table. If the side of the square is 0, the area is obviously 0. If the side of the square is 1 centimeter, its area is 1 square centimeter. It's just squaring that number or multiplying by itself. If we graph that, so what I'm going to do is I'm going to make a graph of the side length and then the area. And if we start to look at what this thing starts to look like, 0, 0, there's our first representative. The side length of 1 has an area of 1, so here's our next representative. The side length of 2 has an area of 1, 2, 3, 4, which is right here. And as we start to see, now you're seeing a bigger growth. Every time that size of the side goes by 1, we see bigger and bigger change. And then the only other one I'm going to be able to fit on here is the side length of 3, which has an area of 9. So now we really start to see this curved pattern that we saw before. Okay, something to keep in mind. Now, in terms of the context of this problem, it doesn't make sense. But quadratics are symmetric, and this is something that maybe Professor Splash didn't indicate to us too much. But if there's a point over here at 1, 1, there's a point over here at negative 1, 1. If there's a point at 2, 2, there's a point at negative 2, 2. Quadratic functions are symmetric, and then you'll see this curved shape. It's almost U shape, and it has a name. We're not going to be too worried about the name of that shape quite yet. So you notice there's this U shape to a quadratic function. Okay. The final thing to really take note about things that are quadratic is we can have things that are this U shape, but quadratic functions can also have this upside down U shape. And that's actually, with Professor Splash, we only saw half of this upside down U, but there can also be this other half in other contexts. If you're hitting something like a baseball, it's going to go up and it's going to come back down. It's going to follow this quadratic path. So that's another shape or feature of these graphs that we need to at least take notice of.